Good afternoon. Welcome to the MIT System Design and Management Program's Systems Thinking webinar series. We're delighted today to host SDM alum Sorin Grama, who's the founder and CEO of Promethean Power Systems, and his business partner, co-founder Sam White, and VP for Business Development of Promethean Power Systems. With that, I will turn it over to Sorin and Sam.
Great. Thank you, Lois. Hello, everyone. My name is Sorin Grama. As Lois said, I'm the co-founder and CEO of Promethean Power Systems. And I have here Sam with me. Together, we started Promethean Power in the summer of 2007. At that time, I had just graduated from MIT System Design and Management program, and Sam quit a perfectly well-paying job in the financial industry so we can begin together this journey on Promethean Power Systems. It's been quite a roller coaster. When I look back, the lessons learned are still the most valuable assets we have. We're still a pre-revenue startup, after all. So Lois has been asking me for quite some time to come in and talk about my experience since graduation, and I've been giving it a lot of thought as to what I could talk about. And, my systems thinking has been greatly influenced by my experience in starting Promethean Power, so I thought I would come in and tell you more about that experience. And that's how we arrived at today's topic, startup thinking, how systems thinking helps entrepreneurial ventures start, grow, and mature. Some of you know, the art of systems engineering has been perfected in large organizations, Ford, Boeing, US Navy, just some of them that come to mind. But systems engineering is applied everywhere, albeit differently, even in startups. So today I want to tell you about how I've applied and in many cases modified some of the systems engineering concepts in our startup. Okay, so the agenda, we'll start with the story, how our system evolved over the years. And I'll try to punctuate this, the lessons learned in a frame-by-frame analysis. And at the end, if you have the patience to wait till the end, I think we'll go through, extract some of the lessons in startup thinking. Let me tell you about the inspiration for our startup, how this all came to be. The inspiration began during a trip to India in the summer of 2007, right after I graduated. Sam and I were traveling to India looking for market opportunities for a technology that we helped commercialize with a group of MIT students at that time. This was a technology that used solar thermal power to produce heat and electricity for school, villages, clinics, and so on. It was a classic case of technology looking for a market. So we traveled all over India, talking to anyone who would care to talk to us, but as you may suspect, the reaction was less than enthusiastic. We didn't really have what they needed. Fortunately, Sam made a call that changed our professional careers. We're in Bangalore on a Saturday morning with nothing to do, and Sam made a cold call to the managing director of Bangalore Dairy, one of India's largest dairies. Within 2 hours, we had a meeting with him and 14 of his engineers sitting around a room much like this one here to tell us about the problems they're experiencing with the milk collection in India, collecting good quality milk in India. And this is what we learned. I'll show you a video of the milk collection process in India. Keep in mind that in India, milk is produced and collected from small farmers. Unlike here in the United States, where you may have a dairy farmer with 500 cows, in India you'll find 500 farmers with 1 cow. So milk is produced by small, marginal farmers in remote regions throughout the countryside. And here's a video of that. Now, this is Sam actually talking. Now, we're looking at the farmers milk the cows and buffaloes twice a day, once in the morning and once in the evening. They keep some of that milk for their own consumption, and then they take the leftover milk to a village collection center somewhere within walking distance. You can see here a farmer coming in. They bring in anywhere from 1 to 5, maybe 10 liters of milk at the most. Not a whole lot of milk. At the collection center, the milk is weighed, measure the fat content, and the farmers get paid at that point. And this is a very good revenue for farmers. Milk is like liquid cash. And from this point on, the milk transfers hands into the hands of the dairy processors, which take the raw milk and quickly have to rush it to a processing center or a chilling center before the milk has a chance to spoil. Raw milk, for those of you that may not know, spoils within 4 hours. So you have to do something with it. And in those hot, humid conditions in India, it's even more important that they get the milk to a processing center as quickly as possible. So in this case, they take a rickshaw or any means of transportation and they rush it over to a processing center. And usually the milk doesn't arrive at that processing center until it's almost ready to spoil. In fact, the other problem that you see with this, and I saw this after watching many times the video, there's a farmer there on the right-hand side of the video that just showed up to deliver his milk. But because this is such a time-constrained process, the rickshaw left before the farmers could deliver the milk. This farmer could deliver the milk. So that, herein, is one of the problems that they're experiencing with this collection model. They can't get enough milk for the growing demand. So, in summary, this is what it looks like. The milk collection process is plagued by these 3 problems. Limited milk supply, they can't get enough milk. This is a growing demand, growing population, and milk is a very important staple of the Indian diet. For those of you that have been to India or are from India, you'll understand what I'm talking about. They use it for absolutely everything. Foods, desserts, even religious rituals. And they can't get enough milk for the growing demand. The second problem with this is the high transportation cost. They have to collect the milk twice a day because cows are milked twice a day. So you have to do that very quickly. So armies of trucks go out twice a day and pick up this milk and bring it to a processing center. So that's a lot of diesel cost, a lot of diesel that gets used in this process. And finally, and probably one of the most important problems, is the fact that it's a much lower quality milk than what you'd get anywhere else in the world. Even though milk is so important for them, the bacteria grows exponentially from the time the milk comes out of the cow to the time it gets processed. So the longer you wait, the lower the quality of the milk. The taste of it changes, and the discerning taste in India, they can actually tell good milk from bad milk. So these are the 3 problems that were presented to us. And obviously there's a very simple and easy solution to it. And I highlighted there in that slide in red. If you can chill the milk right there at the collection point, right there at the source, you solve all these problems in one fell swoop. You can reduce the transportation cost because now you can pick up the milk once a day or once every other day if it's chilled, so it can maintain. You maintain a quality, obviously, because the sooner you refrigerate it, the sooner you lock in that freshness of the milk. So that's what drives the quality. It's chilling the milk immediately. And then, of course, if you can chill it, you can also keep that center open longer. You can invite, farmers can have more time to deliver their milk. So all that can be solved with putting a refrigeration system at the village collection center. Now, we're not the geniuses to have thought of that because, of course, they do that. In some cases, they do that. And they have these milk refrigeration systems that they can put out at the village collection center. But the problem is, in those villages, they don't get reliable electricity supply. So you can't really run a good refrigeration system there that requires 24-hour electricity to keep that milk fresh. And therefore is the ultimate problem is how do we maintain that system, that milk refrigerated at the village collection center. So that's how Sam and I, these are the insight that we got at that time. We realized that the technology we had, that solar thermal technology, wasn't helping to solve this problem. And we had to start completely from scratch. We dropped that technology. Sam and I started Promethean Power, just me and him, no technology, no team, just us and the market insight that we had. And it seemed like a big enough opportunity, big enough problem that it was worth dedicating our professional careers to it. We have enough energy and perhaps some naivete to keep us going. A lot of people ask us, why India? Why have you started this in India? Well, some of you should know that it is the largest producer and consumer of milk in the world. This is a large industry, $14 billion industry, and the desperate need to do something better. So that seems like worth it, a startup, the energy or putting the effort into a startup. It would be worth finding investors. It's a large enough market that would attract investors. And for me, on a personal side, from an engineering perspective, it was a big enough challenge that we could solve. Okay. So moving along, talking about the All right, so now let's talk about how we arrived at the system and the way that's evolved. And just like a good recent SDM graduate, I started analyzing the problem from a systems perspective. First, we had to understand the current solution, because there is a solution, like I said, and it's so-called bulk milk cooler. It chills the raw milk, large quantities of raw milk, at the village. It's an industrial type of cooler, and if you look at it from a top level, it has the power generation unit, there's a cooling unit, and then a cold storage unit where you pour the milk. The electrical power is converted to cooling power, and that's what cools the milk. If we look behind, sort of under the hood of this, well, the electrical power generation unit is nothing but the grid in general. The cooling unit, you can think of a condenser, compressor, the type of equipment you find in your typical refrigerator. But these are larger compressors for larger industrial applications. And then the storage unit is a stainless steel vat, basically like a 500 liters or 1,000 liter vat with an agitator to keep the milk from separating. Now, this is standard architecture and it'd be working fine, except in India, as you recall, the grid is unreliable. So you couldn't work with this exactly in India. So what they do in India, they add a diesel generator. Now, this diesel generator, and I put it in red, doubles the cost of the system on a capital cost and also increases dramatically the operating cost. Because if you have to chill this milk with diesel power, that's 3 times more expensive than grid power. So it's a solution, but not a very good solution, and this is what that's what the Bangalore dairy people were telling us about. This is what a system looks like. You see on the left here is the vat, the milk storage. This is where you pour the milk. There's an agitator, and then to the right, or in the back side of that picture, you see the diesel generator.
This is a traditional system that exists today.
Exactly. So the traditional system, the diesel generator is fairly big. So you can see it's almost as big as the chiller itself. It costs a lot of money, and just getting that diesel out there and running the diesel, that poses a lot of logistics problems as well. So we set out to make a better mousetrap. Now, this is where you enter some bias into the whole system. We had some prior knowledge in solar power, partly from the project that we had done previously with solar thermal technology, partly from I had worked with my thesis when I graduated from SDM was an analysis of the PV industry dynamics, particularly for thin film PV. So we had a reasonable understanding of the solar technology, and we thought it would be a good option to work here. There was a lot of incentive to use solar at the time. It was a growing and an interesting technology, so we thought, why not? Let's try with solar. So in this system, I entered this bias, and I think it's an important thing that people should understand that in all of our system designs, bias, our own personal bias, enters the equation as well. So the system that we decided that we're going to make better is we're going to use solar power. We're going to power this condenser and compressor, and then we're going to use the same stainless steel and agitator system. So we basically made a change into that into the power generation unit. However, solar is expensive, we realized. And refrigeration systems are power-hungry appliances, so you need a lot of solar power to run a refrigerator, especially a milk refrigerator. At the same time, we're a small team, so we didn't have a lot of expertise and even a lot of funding, so we decided to take a shortcut. So we took out the compressor and the heavy-duty, power-hungry appliance from it, and we decided to take a shortcut by using ice as a means to cool the milk. So now we thought, if we remove the compressor and bring in ice, we can get ice delivered at the site and use that ice to actually cool the milk. Solar power remains small, and we can just run the agitator and a few other things with it. So we reduced the cost of solar in the system, and we use ice to do the actual heavy-duty lifting, so to say, the chilling. Now, this is not as crazy an idea as it may sound, because remember, there is a transportation network that goes out there twice a day to pick up the milk. Empty trucks go out there and come back full of milk. Could they go in with ice and come back with milk? So we thought this is, a process change in a dairy, the way they collect their milk, could solve a technical hurdle. We talked to a number of dairies, and you know what? A couple of them said, yeah, I think it will work. And so we had some customer feedback that gave us an incentive. It's like, yeah, this could work. And particularly in Goa, for those of you that have been in Goa, it's a big fishing industry. They have a lot of ice plants around. So people said, especially this particular customer that was interested, Goa Dairy, said, yeah, I think we can make it work. So why don't you go ahead and develop it? We developed it. And we had them come over here and see the system. They said it was fine. It would work for them. And with that bit of customer validation and the limited resources we had, we actually did this. Now, one of the things that was, and I think I'll mention that in a bit later, was the fact that we developed along with it, focused on the rapid milk chiller, which I'll mention a few things later. Let me show you a picture of this system. So this is our first installation in March 2010. You see the solar panel on the left over there. This is at the Village Collection Center, the milk chiller in the middle, and then the actual milk that we collected and chilled with it. Lois, did you want to?
Oh, no.
Okay.
We were just inviting people to ask questions.
All right, so if you have any questions, Lois is taking those questions, and we'll try to, we can pause and answer some of those questions. So this is what the system looked like. Now, we actually installed it. We ran it for about 3 months. It was quite an interesting experience. But the overwhelming feedback was that ice delivery is not economical. They looked at it, 2 out of 10 dairies that came to visit said, I think it will work. But the other 8 said no. And Sam actually spent a lot of time getting these people to come and see this. And customer validation was important to us. We didn't want to do this sort of in vacuum without their input. But as you recall, one of the customers said, yeah, this could work. Well, it turned out it didn't work quite so well. So I wouldn't say this was a wasted effort, because in the process, we learned a lot, and it allowed us to focus on one particular development of it, which I will show again, is this rapid milk chiller. By not having to do with the compressor and the condenser, we're able to develop this rapid chiller. It's a special heat exchanger that takes the milk as you pour it from the farmer and cools it instantly using a surface chiller. It was something that really, it was unique, truly unique for that market, something that hadn't been done at village collection centers. And as you'll see, it stayed on throughout our various systems iterations. But there is always a silver lining in all these failures. So it wasn't a complete failure, I would say. And that rapid milk chiller proves that. So we set out to now develop a second generation system. The feedback was that if we can make the chilling right there on site, then it would be much more feasible. So some fresh funding coming in. Now we got money. We have some more capability to add more people. We decided we can take on the task of actually designing our own solar-powered refrigeration system. And we decided to use solar and grid together. So you can see here how in this decision, funding or money comes in as another decision factor. Oh, we have money now. Let's work on this additional piece which seemed to be missing. But because we're using solar and grid, and solar power is available during the midday, but milk is collected in the morning and evening, exactly outside of the milk, the sun, when the sun is available, we still had to use a type of thermal energy storage. So this system actually became a fairly large and more complex system. Again, we validated this with customers, and in fact, we had one customer who paid for an initial system of this type. He said, I like this, you guys, solar power is what's needed. You're taking away the ice, which I don't like. I want this, and I'll pay for it. And if it works well, I would purchase at least 10 more units for a larger field trial. So we're off to the races, developing this second generation system, a much more complex, larger system, as you can see. In March 2011, exactly a year from our first generation system, we delivered this system, and this is our installation in South India. Well, we have to use more solar power, so this is a 2-kilowatt array that you see here installed on top of the building. On the right-hand side, you see the actual refrigeration system, the refrigerator itself with the compressor and all the gear and pumps and everything inside of that. And just behind it is the thermal energy storage system that we developed to store cold energy when the sun is not available. So the day we finished the installation, and then we worked on this for a month. We had the whole team there in India, Sam, myself, our 2 engineers, everybody was there. The day we finished the installation, the managing director walks in, looks at it, and he doesn't like it. He says, It's too big, too expensive, requires a huge infrastructure. You mean I have to put these solar panels on every building in my villages? I don't even get sturdy enough buildings to put these solar panels. How would you install these over? How would we install these all over India? He had a vision of installing these everywhere in all of his collection centers. So that really, it was very deflating. It was a tough time for us. The order for additional units seemed gone. Our chances to raise another more money was in jeopardy because we didn't have this additional order. And the best we could do is huddle together and decide what to do next. In fact, we had a meeting that day at the site there with all of us, figuring out what went wrong, why did we not see this earlier, and it was a very, very tough time and very introspective.
If you want to go into more details on this, there's a case study in the September issue of Inc. magazine.
Yeah, and we'll give you the link to that. But that follows this journey and talks about the sort of the intense time we had when we were trying to figure out what to do next. So the most obvious choice, and the one that was brought up by some of our engineers, is that we have to drop the expensive part. We have to drop solar. So after 3 years of working with solar power, our solar dreams seemed to be gone. It was something that we really, really wanted to work with. We put it in because we had experience with it, but it turned out it was uneconomical and didn't really solve our problem. So we had to face reality and adjust to it. This was a very tough decision, but even tougher was the decision to let go of our engineering team. Without solar, without all this development to do, we really didn't, there was no need for that, and we were also running short on funds, so we had to let them go. It was a very, very, those were some dark days. But somehow we managed to come out of it. So from our second generation system, full-fledged system, we decided to simplify it completely and go back to a system that only has the rapid chiller because everybody liked that. That's one of the stories that we kept going of validation that said, yes, this seems very interesting, I really like it. Keep the condenser and compressor, throw out the solar, and make it a very, very simple system. If you have to use a diesel generator, that's fine. All of a sudden, the diesel generators pop back into our system picture. So we decided to go, I call this a generation 2.5, because it was basically a slimmed down version of what we had before. And we actually went off and developed this, and it looks something like this. You see the refrigeration system on the bottom, the rapid milk chiller on the top, and we built this very quickly using our engineering resources in India, but then something was still missing. Did we throw out the baby with the bathwater? Did we cut too far? When we were doing the demos in India for this, we had to have power for this. And in fact, it was a Wednesday afternoon. We were expecting some visitors from a dairy to come and visit this, and power was out. And we couldn't demonstrate the system. And we were really scrambling what to do. Fortunately, power came back on, and we were able to demonstrate it. But it really pointed the weakness in the system, and the ultimate problem that the customers wanted to solve is that this doesn't run when power is not available. So in that moment, we decided I had to get back our thermal storage system. I think we had cut too far in this system, so we decided to go back and bring the thermal energy storage back. We still kept the solar out, so we kept that part that was expensive, but brought the thermal energy storage. And now we decided that with the 4 or 5 hours of grid that they do get in those villages, and remember, the villages are not off-grid. A lot of these villages in India have grid. They just don't have enough grid power to run a 24-hour-a-day kind of operation. So we had to store the energy somehow. So we decided to bring back the thermal energy storage, keep out the solar, and that became our Generation 3 system. And all of a sudden, clouds seemed to part, and things just made sense. In our lab in Pune, India, Thursdays is the day when they don't have power at all in that whole region. And that's actually the best time for us to demonstrate the system. We charge the system on Wednesdays with that thermal energy storage that keeps the energy packed up. And on Thursdays, we can chill milk with absolutely no grid power available. And those demonstrations became really powerful, and it's in the end what turned the dairies around. We kept, of course, the rapid milk chiller, which is something unique in the market, so that always remained in all of our iterations. So now I want to rewind back, and I'll show you sort of the evolution of this. So we started with Generation 1, with solar, a very simplified system. We went to a Generation 2, which was the most expensive system, with added everything in. And then we came back to a generation 3 where we took out the solar. So that's been the evolution of our systems. Now, what's the constant thing that's remained all throughout? That thermal energy storage. Now, thermal energy storage turned out to be the clincher, turned out to be the real innovation that we had developed and something that made it work. We didn't realize that in the beginning. We always thought it was solar, and we were the solar milk chiller guys and everything, but it's the thermal energy storage that in the end was the clincher. And fortunately, we developed it because we needed it. Solar was unreliable itself. We needed it, but it turns out that it was really the technology that had to be, that solved the problem. So now we're off to the races because we actually have purchase orders from Indian dairies, and we're developing a system that is going to look more like this. This is a industrial design. We're working with an industrial design firm in India to basically take this thermal energy battery, the refrigeration compressor, the rapid milk chiller, and a milk storage silo, put it together into something like this. The two key technologies that we developed are the thermal energy battery, and this is the one that stores the energy. Remember, it stores it in the form of thermal energy. It's not an electrical battery, it's a thermal battery. And the other two components, the refrigeration compressor and the milk storage silo, are off-the-shelf components. They're designed and sized accordingly for our application. So now I'm going to turn to our lessons learned in this and where we are with this. And I look back at our system evolution, and the way to summarize this is to look at, and what we've done here, we've been pivoting back and forth, trying to figure out the sweet spot in this market. So to give you a better picture of our pivoting, it's best to look at the capital and operating cost. There's two sides of every coin, right? There's the capital cost of the equipment and there's the operating cost of the equipment. You can't lower one without raising the other, and vice versa. If I make a very, very cheap system, it's probably going to be very high operating cost. And if I have a very low operating cost, like a solar system, it's probably going to be a very expensive system. So you have to balance the two. In our first generation one, it was a very expensive system, but a very low cost system, but it was very high operating cost because the ice was fairly expensive. Our second generation system, well, we're using solar power to run most of the time, so very low operating cost, very low running cost, but it was a very expensive system because they had those solar panels. And then generation 2.5 was somewhere where we kind of reduced we reduced dramatically the capital cost, but the operating cost was still fairly high because of diesel. And then finally we came back to a generation 3 system, which is somewhere in the middle, and that seems to be, for us, the sweet spot in this case. All right, so now we've reached this is the end of our journey, and I want to show you some of the lessons we've learned in this. The startup thinking that kind of went into this, and I'll give you sort of 5 bullet points of what I've learned and the things that some of you may be able to apply. Beware of the voice of customer. This is one of a very important topic that comes up a lot in systems engineering, and we learn a lot about this in for example, in applications like. I think it's a very important point, but in a startup, you have to take it with a bit of grain of salt. You saw in our situation where the customer had given us some validation, but it wasn't the right validation. It wasn't exactly what they wanted. They want to see it to believe it. They need to see it in operation. The other thing, I think voice of the customer works well for products that are incremental developments, like, for example, a car. So Ford and other companies use this very diligently, and it's very good for them. But for a product that's a complete innovation, that's something that has never been seen in the market, the customers may not even know what to expect. So I think you have to take it with a grain of salt. I'm not saying that you should ignore the voice of the customer. It's very important that you have some validation and you develop something that's reasonable, that has the right cost, and it matches well with the other existing alternatives, but you have to take it with a grain of salt. Henry Ford had a really good quote once. He said, "If I listened to my customers, I would have developed a faster horse." That's what his customers wanted, right? Before cars were made, people were used to seeing horse-driven carts, right? So customers don't know, in the case of a very innovative technology, they don't know what to ask you for. And that's the case for a lot of startups. Startups don't come up with any incremental developments in technology. They tend to go for something that's never been done before. That's what justifies a startup, the risk of a startup. The investors go for something that can completely change and fundamentally shift a market. Steve Jobs also had a very, very good quote. Some of you that may have recently read the stories about him. When they asked him how much customer validation or market study is done for the iPhone, he said none. It's not their business. Customers, it's not their business to know what they want. I will tell them what they want. Now, Steve Jobs is a phenomenal example, and it was a genius in what he did. And we're not all Steve Jobs. We can't do foresee what he did. But I think there's some truth in there. I think you have to take a leap of faith. You have to go in there and say, I've observed this. I have some vision here. And if you're a good technologist, you go in and try to prove that vision. It may not always work, and you have to be quickly ready to adjust. But I think the voice of the customer has to be balanced in these cases. So that's what I would say for startups to be aware of. Funding. Funding is a very important input in all of our decisions, and you saw that in our systems. For a startup, from hand to mouth, you have to go, you have a certain amount of money, you have to meet a milestone, you know exactly what your running room is. And perhaps this may be true for internal projects in large companies, but for us it's very critical. The company it's a do or die situation. And if I have a lot of money, I can take more risks, or I can try to push for a bigger milestone with more equipment or include more parts into the system. But if I have less funding, I have to make something reach a reasonable milestone before I run out of that funding. So that funding equation always comes into all of our system designs. You saw initially that Generation 1 system that didn't have the complexity of it, part of it because we didn't have the experience and the money. Let's take that out and see if we can use a process improvement instead to get that cooling there. Didn't work out so well, but we tried. In our second generation system, we had more money, and we decided we were able to take on that additional development. But in the end, I'd say funding really has a looms large over the system decision in a startup. We always want to make sure we meet a certain milestone, we have a certain design or a deliverable before we go for funding, because that proves to the investors that you've made some progress, you've shown something, and then you go for the additional funding. Yep. Sam, you feel free to, this is a part of, sort of philosophical discussion in it. Our third startup thinking is optimization. And, system optimization is another big thing that goes a long way in systems engineering. But for us, the optimization we have to do is optimize for minimal set of viable features. By that, what I mean is that I don't spend a lot of time system optimization, fine-tuning this parameter here, there, or doing all kinds of analysis and spreadsheets and efficiency boundaries and things like that. I optimize to get a minimum set of viable features, something that the customers could use. It's not going to be perfect, but it does the job. It proves that what the system could do in the future. It gets the customers to take a leap of faith and order additional units. It gets the investors to add additional money. You just want to get enough viable features into the product. So optimizing, that's how we optimize in a startup. Whether the viable feature is cost, you optimize, of course, always for cost. Cost is always an important parameter. But in general, we try to find the things that make most sense. And you don't want to add anything more than what's viable. You don't want to remove anything that's less viable to make the system work. Our fourth lesson is pivoting is essential. And by that, what I mean from a systems perspective, basically your systems boundaries are flexible. And we've pivoted here at 3 different times, and I think that's not unusual for a lot of startups. Startups, that's their business. They have to quickly turn around and detect, what's the feedback on the product. If it doesn't work, make a decision very quickly. Don't waste a lot of time. Don't sit around and argue why you should keep certain features or not. With the solar power, I was a big proponent of solar power, and we had to finally give up on it. It was a tough decision, but you have to be able to give up on the things that you really care about sometimes. And we talked to a lot of startups, a lot of companies that are in the same situation, and I think it's not a real startup if you haven't done 4 or 5 different pivots along the way. This is where companies run out of money. If you pivot way too many times and your cycle of cash runs out in the process, then you're done. If you have enough cash to continue, but you basically always continue refining that. So for those of you systems architects out there, I would say don't be afraid to add, subtract, bring in various parts into the system until you get it right, until it seems like it works. And then finally, and probably the most important the lesson for me, at least for us, it was stay focused on the problem, not on the solution. This is one of the lessons, and probably the most important lesson I get from PDD, Product Design and Development. And I think for those of you that took that class in SDM, early on they tell you, stay focused on the problem, don't jump to the solution yet. Stay focused on the problem, stay in the problem space, identify the problem correctly, and then design a solution to meet that problem. What we did when we selected solar, we jumped directly to the solution. And it wasn't a good solution because solar power, when you think about it, is also a non-reliable source of power. We're trying to solve an unreliable power problem with yet another unreliable power solution. And that's why solar power wasn't the right thing. And I think we took off our focus from the problem, and we jumped to that solution. We liked solar. It was kind of the right thing to do. You know, even customers liked it, right? A lot of customers came back to us. Oh, solar would be great. We love solar. So that's what. So in the end, the problem we're solving, you know, we thought we were trying to eliminate the diesel generators, but the diesel generators are both a problem and a solution here. You know, yes, they are a problem because they're expensive and they consume diesel and all that stuff, but they were a solution to this, and we're focusing on that. The real problem, the root problem for us, is the unreliable electricity in villages. Not the diesel generator, it's the unreliable electricity in villages. From there, everything else flows like that. Because they're unreliable electricity, they use diesel. Because of diesel, they have all these other costs. If they don't use diesel, they have to transport the milk twice a day. They have lower milk quality. But everything, the root problem is unreliable electricity in villages. And that's one of the things that I think as a system architect, you need to really get to the core of it. Like, where is the problem? Don't fall into a quick solution before you identify the root problem. So with that sort of insight, and it took us almost 4 years to get to that insight, right? Our solution is to cool milk with that 5 hours of grid. We do get at least 4 or 5 hours of grid in villages, and we developed this thermal energy battery. You see here a picture of our prototype in India. The thermal energy battery, we're charged with that 5 hours. It stores enough cooling energy to cool 500 liters of milk, and then to the right of it, you see the rapid milk chiller that takes that energy from the battery and cools the milk. And with this, we can eliminate the use of diesel generators. Because we have that 5 hours of grid, we can rely on that. And once the customers understood this substitution, thermal energy can replace the diesel generator and does the same thing but cheaper, the world was open to us.
And I would just add to the whole problem with trying to listen to the customer and come up with a solution that works. I think you know, as I hear Sorin rehash the stories, you know, I get a pit in my stomach. You know, when I went through, you know, getting all these dairies to come see, you know, 3 different technology solutions. But it was only when, you know, it's easy to say, oh, don't get hung up on the technology. But I think the way we were able to get through that is to finally be honest with ourselves and to say, if I were a dairy, would I buy this?
Yeah.
You know, instead of, you know, getting a few data points from a few dairies, you know, it's hard to do because, you know, why didn't we just do this 4 years ago?
Yeah.
You know, take a step back and really put yourself as a customer, and would you buy this?
That's a good point. You know, you want to ask customers, but the best thing is to put yourself in their shoes and then understand would I buy it. And you know, the thermal energy storage, in a sense, we developed it because we kind of needed it. You know, sort of our own internal need, but it turned out to be really what was the real technology, the real clincher. And that's another lesson I think is if you have to develop something for your own use, it's probably something that other people would want to use as well. And in this case, that's what happened. So if you want a further reading on this, Sam mentioned earlier, the Inc. magazine had a story on this whole drama with solar, case study, Can Solar Power Pay? You can look it up on the Inc. magazine website, just search for Promethean Power, you get that link. So read that afterwards. In summary, I'll just mention a couple of things. I'll put in a shameless plug in here. We have received purchase orders from Indian dairies. We are raising a second round of funding, and we are hiring in India. So for any of you out there listening in, if you're from India and you'd like to talk to us about this, we'd be very interested. Also investors, anybody that you know that you think would be interested in funding this, would like to talk to them. We have a lot of big vision here. We can go from not just milk cooling, but we can adapt this thermal energy battery to other applications, fruits and vegetables, vaccines, vending machines, and so on. So yeah, we're off to many, many races.
And if you're not willing to move to Pune, maybe you have a friend who does.
So here's my contact information. You can get in touch with us on my email or my phone number. And with that, I'd like to conclude and open it up for questions.
Sure, absolutely. Great. There are a number of questions. Our first question: what was involved in raising additional funds? Who provided the funds? What was their stake in the project, etc.?
So raising additional funds, we raised that from a number of angel investors. So early stage, a lot of early stage startups tend to go angel investors. In our case, we also have a social impact that goes with it, because indirectly we're helping the farmers. If the dairies can collect more quality milk, they can pay the farmers more. So there's a social enterprise aspect to it, social impact, and a lot of investors out there looking at this space, and so we have a number of those investors that have come on board.
And we really get the customers involved with that process. And any customer in any industry loves to get involved with that process and being a reference for a potential investor.
How does the solar energy installation capital cost with that of diesel generation system?
So when we had the solar installation, the operating cost of that whole installation was very low, because we were using a hybrid solar and grid. Just to be clear, partly solar, partly grid power, trying to still use whatever grid was available, and then supplement that with solar, and vice versa. When solar wasn't on, grid was on, typically at night. So the capital cost of that was very expensive because of the solar panels. The solar panels themselves were like half the cost of the system, I think. But the operating cost, consequently, was very low, because we were using free solar power, basically, to run it for most of the time. So, or for half the time. So, I'm not going to give out the numbers and everything, but it was very, dramatic, quite low, the lowest operating cost you can get, but also one of the highest capital costs.
What liquid was used for the thermal heat exchanger? How long did the liquid remain cool on its own?
The liquid is something proprietary. We don't disclose that, but the liquid could hold for 24 hours. In fact, the way these systems are, the thermal energy battery gets charged and discharged almost on a 24-hour basis. So it gets charged usually overnight, gets discharged a bit during the day, and then charged again at night. So we don't need to keep this battery. The liquid doesn't need to hold too long. There's always some power available within a 24-hour period to top off the battery and keep it recharge it back to 100%.
What is the capital cost of a diesel generator in India?
The capital cost of a diesel generator varies anywhere, but in the kind of systems that we're talking about here, they go anywhere from $2,000 to $3,000. So fairly expensive. These are 5, 7 kVA systems, 10 kVA type diesel generation systems.
In your opinion, how has the systems thinking vision changed the way you tackled the design of the chiller?
Very good question. I think my systems thinking is changing in the sense that I think of the boundaries of the system a lot. Like what are we developing? Where's our core expertise? And where do I need help? Further going forward from this, for example, we may not develop all parts of the system going forward. We will retain the thermal energy battery, and we may want other people to develop attachments to this battery, like a vaccine cooler, for example, a fruits and vegetable cooler. That becomes somebody else's part. So my system is going to trim down even further to a core technology that I want to develop, maintain, and patent. So I think my systems thinking goes a lot. The boundaries, as I said earlier, are very flexible. It's a rubber band. If it makes sense to include this piece for this application, you do so. If you don't have enough funding, then you remove this piece. So that's the part that you really want to be very flexible in your system design, and be creative. I mean, those boundaries, it's like a box that kind of constrains you. Maybe you think outside the box, do other things.
How to create the initial system conceptual model or the block diagram.
Can you repeat the question?
Yeah. How to create the initial system conceptual model or the block diagram from the problem you're solving or the first solution of you?
How do we create the system from the block diagram? Is that the question? How did we create that system from a simple block diagram?
Yeah. Yeah.
The block diagrams that I showed you here are kind of a post-mortem. I've created them after I've done the system, but it wasn't so simple like we put these 3 blocks and said, we're going to innovate here and do that there. But you analyze a lot of what's happening, what's already out there, and where you can make a difference. You look and, you have to analyze the systems. You have to kind of, in your mind, break them down and understand the different pieces, how they all connect with each other. I probably have some other much more detailed diagrams here, and this presentation I've showed you a very, very simple sort of schematic of it.
Thinking about systems analysis and the case afterwards, would it have been possible to use deeper analysis on needs and available solutions for finding the solutions sooner?
That's an interesting question. Could we have done a more needs analysis and deeper analysis? Possibly. I mean, I think we certainly made a few mistakes along the way. We could have iterated faster and gotten to the solution a little faster. I think we did do a very thorough market study in India. This is another lesson that we learned from our product design and development. We took a month in 2009. We actually traveled all over villages and everything, looking at the whole milk collection process. So we call it the milk trail. Follow the drop of milk from cow, literally from cow to consumer, and watch how that milk traveled, where it goes, how long it stays, who pays for what, and travel with the trucks in those rickshaws, and interview people along the way. It was actually quite a fun trip, and we have a video of that probably on our website.
Yeah, but just a lesson learned: never do it with a sales guy, because I was selling to the decision makers during that process where we're just trying to figure out the needs.
Yeah, but I think we started to analyze the needs. I mean, we did do a fairly thorough market research, but in the back of our minds, that solar solution was kind of always there. We always wanted to use it. So I think, we had biased too early, or sort of introduced that bias too early into our thinking, and that's probably something that we should have been more quick to spot and remove if it didn't make sense.
How do you manage innovative ideas without customer input that are ahead of their time? There's a danger of chasing a dream whose time has not come. What can you comment based on your experience?
That's a very good question, and I think, I struggle with that a lot, because you do want some customer validation sometimes. I mean, they are pointing you in the right direction. But I think one of the things that we do, we talk to a lot of people, we talk to a lot of customers, we see different opinions from different customers, something that customers don't see themselves. They're pretty focused on their own sort of silo. But then we talk to 10 customers that tell us slightly different things or similar things, and we start to analyze the patterns. We also have the benefit of looking at other technologies in other areas. We're not milk refrigeration guys. We didn't grow up in the dairy industry. We come with some may call it naivete, but it's sort of a fresh thinking, and we look at, hey, how do they do chilling in other applications? Can we use that idea from there and apply it here? So the fact that we have a more broader perspective, I think, helps. And that's what allows us to come in with some innovative ideas and then tell customers, this is better for you. You have never seen this because you, Mr. Customer, have always focused on the dairy industry. You've always purchased the same system from the same vendor for 20 years. But here, what they've been doing in other industries, take a look at that. So I think we're cross-pollinating in some way, and that's how we are able to come up with some innovative, creative ideas. You know, the concept of thermal energy storage is used in air conditioning systems, in some large air conditioning systems. It's not used in the dairy industry. And here's an example of taking a technology that was developed elsewhere in some form or shape and trying to adapt it to another industry.
How do you manage innovative ideas without, I just read that one, my apologies. How do you price your final units? What were the preferred payment terms, i.e. cash up front, lease, etc.?
The easy way is to do what we did was, figure out what our costs and add 30%. And I don't think we've done a good enough job in pricing it based on what the value is. So it's still work in progress.
Yeah, I mean, I think there's a bottom-down, sort of bottom-up and top-down analysis. Bottom-up analysis, you just add up all your components, how much you paid for everything, you add a markup, and that's how you sell the system. Top-down is you look at, what does system do? This is a much more difficult one. What is the value that it creates? And, how can you compare with the existing alternatives and you try to be better than that? So it's an art. It's a bit of both. You have to go in both directions. And like Sam said, the value that it creates is very important. It's very difficult to identify well.
Because we're asking the dairies, well, what is the value of this? Oh, well, the shelf life goes from 2 days to 15 days, like every other day instead of twice a day. And then you have to say, aha, so here's the price.
Realizing you are still a startup, but past the initial startup actions you highlighted, how does ST continue to play a role in your organization? Systems thinking.
How does ST thinking? Well, I think it continues. I mean, we're constantly innovating and adding new types of products and systems. I mean, the thermal energy battery that we're developing with the milk chiller for the milk chiller application is just a start. It's our proving ground, and we plan to grow from there into another application that we've designed. For example, is the fruits and vegetable cooling systems. It's another area, very untapped area in India. $10 billion worth of fresh produce will spoil because they don't really have a way to cold store it. They consume it either immediately, fresh, or some of it goes to waste. So we're constantly, I mean, there's always new systems to think about, and we're always, I think, apply the lessons that I showed you earlier, those 5, and I'll scroll back to them, the things that we mentioned. I think we're always gonna do these, and number 5 is staying focused always staying focused on the problem. Even with this, seems like we have a solution now, but we have to be very, very careful not to apply a solution where it may not make sense.
Right. One thing that I've learned in the process of trying to raise money is it really makes customers nervous when I used to say, oh, by the time this gets copied, we'll be on to the next generation. Because they want to see one system locked down, frozen, and mass-produced. And they don't want to hear this constant innovation. So it's a good lesson learned.
Yeah, focus is a really important another part that once we nail this, we haven't nailed it yet, but I mean, we're working on sort of refining this milk cooling application. But we need to prove this and get it far enough to show investors, show customers that this is real, that this could work, that this, other people may be able to partner with us. And then we go into these other applications. But you definitely want to create that initial bridgehead into this market. And then, this is from Entrepreneurial marketing concepts. You go into the bowling alley where you go and after, adjacent markets that you can attack with the same or similar technology.
Your startup thinking points seem right on, but sound a lot like the innovator's dilemma principles from Clay C. What were the interesting dynamics in your ecosystem or design that SDs helped you uncover? Stated differently, was a systems dynamics approach critical to reaching your endpoint, and if so, how?
It's interesting, the systems dynamics question. I haven't really thought of it so much as and I haven't done like an analysis of a system dynamics, like a classic system dynamic analysis with it. I think, to be honest, a lot of it is just you kind of try something, it doesn't work, you try something else, and I wish I could say I've done a formal study of all these things. I had done some various analysis in Excel and things like that, typical SDM type analysis, but not a very deep, thorough. I didn't do like a total system decomposition like we did in systems architecture. I didn't do a few other. I think it's more. You're drinking from a fire hose, so you have to go pretty fast. You do a lot of things. You try, and it doesn't work. You try something else. Not sure if I answered your question well, but it's a very well thought out question. It's something that I would have to think about a little deeper how to answer that.
Thank you. Very inspiring. Reflecting on this experience, if you would go back and do the business plan you did at the beginning, what elements would you feel that were better to be more certain of at the time? And what do you think was overthought of and was better to be left after launching the first generation?
The part that we did, I think, well, and it's worked out for us, was the focus on the market. Through all these pivots, we kept focused on the same dairy market in India. We never let go of that vision. We knew that there was a problem, it hasn't been solved well, and we have to stay focused on that. So I think from the business plan perspective, that's something I would keep, and you always want to lead your business plan with the problem. What is the problem? What is the market? And then eventually you explain the solution. I see a lot of business plans or presentations where people come in and talk about this fancy technology that they have, this thing that I've developed, and it's go into all the details and all this stuff, and then later, half hour later, you find out what they're trying to solve with that. That pretty much tells me that it's a technology looking for a market, and it's not always the best way to start the startup. You want to focus on the problem, understand it, identify the problem, identify the market, and then develop the technology for that. You've seen here that we haven't always applied that concept scrupulously, but it's something that I think if you're thinking of doing a startup, you absolutely must do this. You absolutely need to understand the problem, find that market where that problem, or maybe you come from a market where some problem exists, and then, only then, develop a technology for it.
I'd like to just jump in for a minute. We have several more questions, so we will be extending this session beyond 1 p.m. For those of you who need to leave, however, I'd like to let you know two things. First of all, we will be posting the entire recording on the SDM website, and we will be sending out a link to that later this week. Secondly, we hope you can join us for our next webinar, which will be held on December 12th at the usual time, noon to 1 p.m. We have Dr. John Billy speaking on using lean thinking to transform a large academic medical center. In this case, it will be the medical center at the University of Michigan. Thanks to all of you who are able to join us and who need to leave us shortly. And for the rest of you, I'm going to give you back to Sorin and Sam.
All right, our next question. Does the community get involved in the investment, i.e. microfinancing?
It's not, this particular system is not exactly a microfinance type system. It is a fairly expensive industrial cooling system. The farmers themselves don't buy this. They can't afford it. It's the dairy processors that will buy it and install it in those villages for farmers to use. So that's an important aspect of our business plan. We're selling this to businesses. It's a business-to-business transaction. Dairies will purchase these, maintain them in many cases. So we haven't really discussed any microfinancing schemes with anybody.
Very clear presentation, very valuable experience. The speaker mentioned a course that he took at MIT. What was the name of the course?
Well, the courses that shaped most for me was the product design and development course. This is the one where it's actually a really fun course. And I saw Fernando online. Fernando Espinosa was one of my classmates. Fernando, you remember this course. We had a lot of fun. They actually give you, you have to select a problem, and you design a product during this course. I think it's also taught in the MBA curriculum. But basically, you throughout the course, you design a product. You first identify the problem. You come up with multiple solutions. You narrow down that solution to one, and you actually build it and present it. And some companies actually get started like that from this course. But that really, this staying focused on the problem, not on the solution, that comes directly from product design and development class. The other one was the systems architecture class. I think that also which was part of curriculum of the system design and management, a core curriculum of SDM, is the systems architecture class, which makes you think about system decomposition and what are the parts, what are the sort of relationship between parts, where is the user, where does the architect come in, and what's the benefit to the user, and things like that. And it makes you think more like systems, and it's from a systems approach. So I'll say these two classes were very important. Entrepreneurial marketing and some other classes that help you draft a market research and product rollout plan and things like that are also come to mind.
When we talk about startup thinking, is it recommended to tackle problems with a top-to-bottom approach instead of starting with the details?
Is it recommended to identify problems?
Is it recommended to tackle problems with a top-down approach instead of starting with the details?
Interesting question. If I had a choice, I'd think a top-down approach. I mean, you understand the problem at its surface, then you dig down deeper and deeper, and then make sure it is the root problem, and then you design a system to meet that, to address that problem. I think you don't want to dive too deep into the details before you understand the problem at the top level, I would say.
Now that you have identified the right solution, what issues do you see ahead with manufacturing and scaling?
There are many, obstacles left on this. I mean, we now have to manufacture these units. They are, fairly big industrial units. We have fabricators identified in India, but they're fairly small fabricators. They can produce 10 units a month, but it's not going to scale it up to the hundreds or thousands units a year that we plan to make for this. So I think from now on, it probably goes into more of a we're going to go through some more system optimization. These are the things that we're going to walk into, being ruthless about the parts that need to stay, the parts that need to be taken out to reduce the cost. So cost reduction is a very, very important aspect to this. We've kind of figured out the solution, we cobbled it together, but now really to scale it up, you got to reduce the cost. So now it becomes more of a traditional product development, and how do we make this something mass produced and mass consumed?
Okay, great.
Okay, well, thank you all for joining us, and Sorin and Sam, thank you very, very much. This was terrific, and we hope you can join us for our next webinar on December 12th. Happy holidays, everyone.